talk about the ethics of cloning, that we could harvest their organs, but we already have examples of clones. They're called twins. Have you dreamt about taking all the organs out of your system? In a dinner conversation? It will now, she says. Okay.
My answer's yes.
Get started. I don't know, I gotta like land this shit. How many more slides I gotta do? We okay? We all cool? So chemistry, this is really cool. You can look at the abundance of elements in the universe, and the number one element in the universe, if you count them all up, is hydrogen. It's the simplest element. The number two element is the second simplest, and is helium. That was at the top of the noble gases. The universe is like 90% hydrogen atoms, about 8% helium. A third is oxygen. Fourth is carbon. Fifth is nitrogen. Then my favorite element of them all, other. Okay. So we can ask the question, what is life on Earth made? Are our ingredients exotic? Because then you could argue that we are something special. If we list the ingredients of life on Earth and we're made of an isotope of bismuth, you can say, hey. We are bismuthians, you know? You could. All right. What is the number one molecule in our body? Water, thank you. And water is, spell out water. H2O, thank you. So we have two H's, which is hydrogen. So the number one atom in the body actually is hydrogen. There's no helium in us because we learned that helium is inert, so it is of no use to you. You can inhale it. Sound like Mickey Mouse, that's cool. Young student is anything. So you can inhale helium, but it's not going to kill you unless that's all you breathe. Then you would suffocate from it, but it's not going to chemically kill you. So I should have actually put a line through it, but it's in bold or something. It's not a good symbol. But anyhow, so we don't have any helium. So next in our body is what's connected to the hydrogen in the water molecule. Oxygen, there you go. And as you know from watching Star Trek, we are carbon-based life. That is the next ingredient in life on Earth. And what comes after carbon? Nitrogen. Together, class, what comes after nitrogen? Other. Life on Earth is one for one made of the same ingredients in order that you find in the universe. In order. Some people say, I don't feel special anymore. Because we're not made of an isotope of bismuth. I would say, how much more special can you be? We are of the universe. These ingredients were forged in the cores of stars that exploded and gave their lives to enrich subsequent generations of other stars around which would orbit planets. And life. You know why we're carbon-based life? Because of all the elements on the periodic table, carbon is the most fertile. Carbon. You can make more molecules with carbon than you can all other kinds of molecules combined. So if you're going to find an atom on which to base the complexity of life on the entire table, carbon is your atom. Did you know that Jon Stewart from The Daily Show, did you get The Daily Show up here?
Yes.
Yeah. So Jon Stewart, I had him on my radio show, Star Talk, and that's when I learned he majored in chemistry. in college. Got 4 chemistry majors right there. He began in chemistry. He would later switch to psychology. But he put in 3 years of chemistry. 2 or 3 years of chemistry. And so I asked him the geeky question that you have to ask someone who's majored in chemistry. I said, what's your favorite element? He said, carbon. So I said, why? He said, because carbon is the slut of the periodic table. Every which way, with every element. I've never quite heard it put that way before. We opened our new planetarium in New York. I was looking for your planetarium, and it was like, I saw a dome, but not, like closed for business signs on the door. What's up with that?
Help us.
How many years ago? So you've had an unused spherical dome for 15 years sitting on the side of the street.
We just have a bath.
Okay. Okay, so somebody's going to take that image of Canada disappearing from the map and hand it to somebody. Okay? I'll make sure somebody has it. In the Hague Planetarium, when we opened it, one of our opening, like the first episode of Cosmos, we did a zoom out from Earth. And Earth shrinks, and then the solar system shrinks, and everything squeezes down to nothingness. And for some people, they feel small. There was a professor of psychology who saw the show and sent me a letter afterwards. Okay? I'm assistant professor of social and cultural psychology at the University of Pennsylvania. I'm writing to discuss the possibility of a research project in collaboration with the planetarium. My research focuses on the psychological experiences associated with feelings of insignificance. And I thought, that's a hell of a job to have. Honey, I'm home. Oh dear, how was your day at work? Insignificant. It'll be better tomorrow. No, it won't. How does that even work? It's an actual letter. I would be grateful if we can... I recently saw the space show at the planetarium, and needless to say, it was the most dramatic elicitor of feelings in smallness and insignificance that I have yet encountered. I assert that you can only feel that small if you entered the planetarium show with an unjustifiably high ego to begin with. Because then you have a place from which to fall. But if you went in there with no ego at all, and you zoom out to the rest of the universe and say, whoa, we figured this out. Our, whatever our brain waves or gray matter figured this out. Whoa. Whoa, humans are cool. It's a pretty famous image. I'm just saying, every smile. Can we dim the lights a bit? Just to get, Ooh. Let's keep it at that for a minute, but ultimately I might want those out as well. So this is an image taken by the Hubble telescope. It's called the Hubble Deep Field. It might be the Ultra Deep Field. Let me look at this. It's the Ultra Deep Field. Anyhow, there are 4 stars in this image that are sitting right on our nose and we're looking out from our galaxy, like looking through a screen door out to the rest of the universe. The stars have spikes. So here's one of them right here. And the other one is above my finger in mid-frame. There's one on the edge here. And there's one way up in the upper left. Everything else is a galaxy, such as the Milky Way, containing hundreds of billions of stars. And among those stars are those that manufacture the elements that you saw on the periodic table and scattering them into the galaxy, enabling things such as life to form. And this unfolds in every one of these galaxies. Every single one of them. to the edge of the universe. Hang on a sec. So, what I've said before, and I'm on YouTube commenting on what I think is the most astonishing fact about the universe. It's that stars manufacture these elements, and we think of ourselves as being in a universe, looking out and we're here and that's there, but in fact, more significant than that, knowing the origin of our elements is that the universe is in us. And I don't know any, that's the most profound, that's even spiritual. Forget profound, that's spiritual. That's a connectivity to the cosmos that should elevate your ego. Not that you're better than anything, but that you are a participant in the great unfolding of the cosmic story. This picture shouldn't be here. But it's really beautiful, so let's get past that. I want to tell you about Carl Sagan's pale blue dot. So Voyager 1 was the third spacecraft to have enough velocity to leave the solar system, but it's traveling the fastest, so right now it's the farthest out there. In 1990, it had already completed its tour of the planets. It had passed Neptune. And Carl Sagan convinced NASA to get Voyager to turn its camera back towards the inner solar system and take a selfie of Earth. And so, in so doing, you see this little pale blue dot, barely a couple of pixels across. That exercise was reprised by the Cassini spacecraft in orbit around Saturn just a few months ago. This is Saturn in an image where Saturn has eclipsed the sun. The sun is behind Saturn in this image with sunlight peeking through the outer cloud layers of the ball. That's what gives it that circular glow around the ball itself. And the rings are illuminated from the underside, so they have this eerie glow to them. Now, it turns out if you get closer in, Cassini is orbiting Saturn. Orbiting Saturn. If you get closer in, you find Earth. That dot is Earth. We're looking back towards the center of the solar system. So Earth is going to be somewhere in that frame. That's Earth. And I'd like to end with a recitation from the Book of Carl. On the pale blue dot. Can we take all house lights to 0? Yes. Yes. Oh yeah. If you look at Earth from space, you see a dot. That's here. That's home. That's us. On it, everyone you've ever heard of. Every human being who ever lived out their life. The aggregate of all our joys and sufferings. Thousands of confident religions, ideologies, and economic doctrines. Every human, every hunter and forager, every hero and coward, every creator and destroyer of civilizations, every king and peasant, every young couple in love, every hopeful child, every mother and father, every inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there on a mote of dust. Earth is a very small stage vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and in triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of the dot on scarcely distinguishable inhabitants of some other corner of the dot. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. It is up to us. It's been said that astronomy is a humbling, and I might add, character-building experience. To my mind, there's perhaps no greater demonstration of the folly of human conceits than this distant image of our tiny world. It underscores our responsibility to deal more kindly and compassionately with one another, and to preserve and cherish that pale blue dot, the only home we've ever known. Thank you all for your attention. Hang out for some Q&A. I'm game for it. Can we do that?
Good evening, everybody. My name is Michael Reed, and I'm the Director of Education and Public Outreach at the Dunlap Institute. And on behalf of the Dunlap Institute, the Dunlap family who are here with us today, and the University of Toronto, I'd like to thank Dr. Tyson for a really magnificent lecture tonight. And he's very generously volunteered to stay around for a little while and ask questions, even though he disclosed to us.
I'm going to answer the questions, not ask them.
He's got to fly out early tomorrow to film yet another episode of Cosmos. So I'm going to ask those of you who have questions. There are microphones on the ground floor here, staffed by some of our graduate students. So if you'd like to ask a question, please come on down to the microphones.
And wait, and if you're in the cheap seats up there, we can find you and just speak up and I'll repeat the question. Because you don't have microphones up in the, right? So I don't want to leave you out. Even though you got here late, I don't want to leave you out. Okay, we have a question over here. Oh, and he just wants a big, well, you don't have the microphone yet. So, yeah, so there's a microphone there, but.
I've been listening to years on Star Talk Radio into astrology since I was a child.
Astrology? I knew what you meant.
I just want a big high five for all your accomplishments and everything you've done.
Okay, come on up. Question at the microphone.
Hi there, I'm Karen.
Hi, Karen.
So I also share concerns about what's happening, especially in the U.S. and a little bit here about sort of the dumbing down of people and are the pressure to do that. So I'm wondering, do we have to wait for a generation of anti-scientists to die off before we can go back to restore science to its rightful place?
Yes. Okay, next question. The question was, do we have to wait for a generation of anti-scientists to die? There's some of that. that that's going on? I mean, it's, in the United States, when racism was rampant, there was a whole generation of people that would never sort of convert in that one, and they just got old and died. The next generation rose up not knowing anything about segregation or Jim Crow or anything else, and they had a different awareness and understanding of the world. Occasionally, it has to happen that way, and I would just hope not, and that's why we made Cosmos. Okay, thank you. Question right over here.
Thanks for your talk and for everything that you do to try to educate the world about science. Do you have any tips or advice for scientists who need to communicate their message to the public or to the media about how to do that effectively?
Yeah, thanks. So I think some of the anti-science sentiment, dare I even say this, came about because of the conduct of scientists themselves, acting as though they are part of a priesthood. No one is allowed in. They have a lexicon you don't understand. They think of themselves above you. They don't watch television, so when you say you enjoy a reality show, they look at you like you're an idiot. How could you possibly enjoy a reality show? Actually, it is entertainment, by definition, because they're very successful. So there's an attitude that I have found that pervades the academic community in some measure, but also just the general intelligentsia, looking down on those who don't know better or less educated than you. And without any kind of sense of understanding or compassion of their circumstances, I'm not surprised that there's some backlash to the community of people who see themselves as intellectually different and distinct from everyone else. So part of the challenge here is to not say, I'm sitting up on the throne, come to the throne and kiss my ring. It's, where are you? Let me come to you. And let's talk about this. Look at how fun this universe is. Look how fun these bugs are, or these plants are, whatever is your scientific passion. If you have passion, it leaks out of you and other people know it. And so, I don't see it as something that is not without the responsibility of the scientists themselves to solve. Okay. All right. The burnt orange shirt, yes, and speak up loud so we can hear you. Hey. By the way, we can all hear you perfectly, right? Even up under the thing there? Yeah, so great voice, good acoustics, go for it. That's an excellent question, and we've actually posed that question among ourselves. Because if we're made of matter, and we've got a sun and planets, and could there be dark matter sort of communities? No. No, but because we do know a couple of things about dark matter. It doesn't stick to us. If it did, we'd be able to detect it in other ways other than its gravity. It doesn't even stick to itself. And you have to be able to stick to yourself to make a planet. Because that's what the atoms did to make molecules. That's what the molecules did to make rocks. That's what the rocks did to make a planet. Dark matter passes through itself, as well as through us. It has mysterious properties that will prevent it from ever becoming a dense pocket of itself. Thanks for your question.
Hi. My question is, growing up, I had a real problem learning the order of the planets until somebody told me my very eager mouse jumped straight up Nathan's pants. And now that
Jump straight up.
Nathan's pants.
Nathan's pants.
Right, it gives you the order of the planets. So I was wondering now that you've managed.
That's the first of that I ever heard. Did you have mice? Did anyone else hear about Nathan's pants?
9 pickles.
My question was going to be, now that we don't have Pluto, could you come up with a new mnemonic for...
My very educated mother just served us nachos.
Yeah.
lot of it does have to do with science journalism and how scientists comport themselves and the ability to bring people up to your level rather than talking down. But I also think that education, less so in Canada because we have a lot of government assistance, but I know in the United States it's a huge investment monetarily. So I find with the internet, a lot of people are self-educating through stuff. And the paywalls in journals, like I'm a master's student and I still come up against paywalls even through my institution. And I think that's a huge barrier to education. So that's science coming up against itself. But I'm wondering what your opinion is on self-education on the internet and how valid that is.
The problem with the internet, there's more than one problem. What I would say is at the top is no matter how crazy your idea is or how wrong it is, if you just type it into Google, you will find everyone else in the world who thinks just like you. Leaving you to believe that you have a legitimate thought about the world. Because you're getting confirmation from others who think just like you. Gives you a false sense of what is true. So if you are sure Earth is flat, type in flat Earth, you'll go to the Flat Earth Society pages, you'll go, and there's a whole, they have conferences, and you say, Earth is flat. No, it's not. Okay? So at some point, you need some referencing outside of this search mechanism that gives you the illusion of truth. And I don't have an easy answer for that. What I try to do when I teach is teach people how to think about the world, how to interpret information, how to put it together into a new idea. I'll never teach you what to know. And the teachers who are trying to get you to memorize the planets in order, no wonder why people got upset when Pluto got yoked from the list. Because your understanding of the solar system was a list. That's not how you understand the solar system. The solar system is, we have gaseous planets. We have rocky ones. We have icy bodies. We have rocky bodies. You don't count them and believe that that's science. You understand their properties. You compare and contrast them. Do you know Saturn has aurora in its northern and southern hemispheres? Just as we do here? And surely, well, you've all amassed yourselves near the United States border, but if you get north in Canada, you might see some aurora every now and then, the northern lights. And so, books tend to have some filtering there, although we saw some interesting exceptions. I don't know that I think if you stick with the .edu sites, you'll do a little better. These are the sites that tend to be produced in universities. And most universities have awesome posted course syllabi and book lists and all the rest. And MIT now is coming up with open online courses where you can take those will have been vetted for the crazy, crazy things. And you can at least anchor yourself on a path to enlightenment. Okay. Any others up in the, yes, right here. Louder.